Download this code from codegive.com, link in the description below. Tutorial: Identifying anomaly images using convolutional autoencoders. Anomaly detection in images is a vital task in various fields such as medical imaging, industrial inspection, and security. One effective method for detecting anomalies is using a convolutional autoencoder, CAE. This tutorial will guide you through the process of using CAEs to identify anomalies in images. What is a convolutional autoencoder? A convolutional autoencoder is a type of neural network that consists of two main parts, an encoder and a decoder. The encoder compresses the input image into a lower dimensional representation, while the decoder reconstructs the image from this representation. During training, the model learns to minimize the reconstruction error, the difference between the input and the output. Anomalies can be identified by measuring this reconstruction error on new images. If the error exceeds a certain threshold, the image is likely an anomaly. Prerequisites: basic understanding of Python and deep learning concepts. Libraries: TensorFlow, caes, NumPy, and Matplotlib. You can install these using pip. Step 1. Prepare the dataset. For this tutorial, we will use the SAFAR10 dataset, which consists of 60,032 x 32 color images in 10 different classes. We will treat one class as normal data and all others as anomalies. Step 2. Build the convolutional autoencoder. Now, we will create a convolutional autoencoder model. Step 3. Identify anomalies. To find anomalies, we will use the trained autoencoder to reconstruct the test images and calculate the reconstruction error. Conclusion: in this tutorial, you learned how to identify anomaly images using convolutional autoencoders. This approach can be applied to various datasets and applications by modifying the model architecture, the dataset, and the thresholds for anomaly detection. Feel free to experiment with different datasets and parameters to further enhance your understanding and performance of the model. Tutorial: Identifying anomaly images using convolutional autoencoders. Introduction. Anomaly detection is an essential task in various fields, including industrial inspection, medical imaging, and security. In this tutorial, we will learn how to use convolutional autoencoders, CAEs, to identify anomalies in images. Convolutional autoencoders are a type of neural network that can learn to compress and reconstruct images, making them effective for anomaly detection. What is a convolutional autoencoder? A convolutional autoencoder consists of two main parts. One encoder. This part compresses the input image into a lower dimensional representation, latent space. 2 decoder. This part reconstructs the original image from the latent representation. The idea is that the autoencoder learns to reconstruct normal images well, while it struggles to reconstruct anomalies, leading to higher reconstruction errors. Prerequisites: Python 3.x. Libraries: TensorFlow, caes, NumPy, Matplotlib, and OpenCV, for image processing. You can install the required libraries using pip. Step-by-step guide. Step 1. Data preparation. For this tutorial, we'll use the NIST dataset of handwritten digits as our normal data. We can treat digits 0 to 8 as normal and 9 as an anomaly. Step 2. Build the convolutional autoencoder. Now, let's create a simple convolutional autoencoder architecture using caes. Step 3. Train the autoencoder. We will train the autoencoder using the normal images. Step 4. Anomaly detection. After training, we can evaluate the model on both normal and anomaly images. We will compute the reconstruction error and set a threshold to detect anomalies. Step 5. Visualize results. Let's visualize some of the reconstructed images and highlight the anomalies. Conclusion. In this tutorial, we demonstrated how to use convolutional autoencoders for anomaly detection in images. We trained a model on normalness digits and used reconstruction error to identify anomalies. You can extend this approach to more complex datasets and applications. Further reading. Deep learning for anomaly detection, explore more advanced techniques and architectures. Transfer learning, consider using pre-trained models for feature extraction. Other anomaly detection techniques, investigate methods like one-class SVM, isolation forest, etc. Feel free to modify the code, experiment with different data sets, and enhance the model architecture for better performance.